Question 5c. Find the length of the radius of the sector of the circle shown in the diagram. Give your answer correct to the nearest millimetre. The arc length of a circle, L, is given by the formula L equals theta degrees over 360 degrees times 2 times pi times r, where r is the radius of the circle and theta degrees is the angle subtended or formed at the centre of the circle by arc L. Now the length of arc L is 8 centimetres, but the question asks for the radius to be expressed to the nearest millimetre. So the first step is to express 8 centimetres in millimetres. So converting 8 centimetres into millimetres by multiplying it by 10, 8 centimetres is equal to 80 millimetres. Now substituting L equals 80 into the arc length formula and solving for r, we get 80 equals 30 degrees over 360 degrees times 2 times pi times r, which simplifies to 80 equals 1 over 6 times pi times r. Multiplying both sides of the equation by 6, we get 480 equals pi times r. Dividing both sides of the equation by pi, we get r is equal to 480 divided by pi, which equals 152.788 and so on, which rounds to 153 millimetres, correct to the nearest millimetre. An alternative solution relies on theta measured in radians and uses the formula L equals theta times r, where L is the arc length, theta is the angle subtended at the centre of the circle by arc length L measured in radians, and r is the radius of the circle. So L is equal to 80 and theta is equal to 30 over 180 times pi, which equals pi over 6 radians. So substituting pi over 6 for theta and 80 for L, we get 80 is equal to pi over 6 times r. Dividing both sides of the equation by pi over 6 to make r the subject, we get r is equal to 80 divided by pi over 6, which equals 152.788 and so on, which rounds to 153 millimetres.